Tensor systems make Swole-Crete by streaming ultra-high molecular weight fibers into concrete. And we've had some large-scale success. But the proof is in the pudding, and that comes from research labs. This graph shows 28-day Swole-Crete specimens, if I might say, towering over the green line of a typical fiber-reinforced concrete specimen per ASTM 1609. We like to say that green line represents 60 years of structural engineering success in our shade. In this case, we're doing a test on a 7-day specimen, and we're just taking the slack out of the system right here. This is the first crack. Notice it just fell off a little bit. It didn't fall off 10%, but it's already taking load again and taking it beyond what brought the first crack. Okay, here's the second crack. Note the slope on the force lines right here, which show the stiffness is pretty much maintained. And the system is still taking significant load, and quickly. We're almost to 0.2 of an inch deflection. So now after the third crack, we're over a 1/4 inch deflection, and we're still taking serious load. We decided to take a look at the cracks because we got 0.3 of an inch almost of deflection. That crack shows that this beam is cracked completely to the top on this side. And as we look across at this one, we can see that this crack also goes almost exactly to the top. So I got 3 pieces of concrete here carrying 2.5 tons. At almost 4/10 deflection, the limit of the LVDTs, and some interesting popping sounds are coming from the beam, but still taking force and setting a new maximum over 3.5 tons. Okay, the LVDTs have exceeded their limits, so we got some pretty bent concrete with 3.5 tons on it, and it is starting to get squishy. You can see the force line starting to, the slope is starting to flatten out, and so we're going to do something different now. We're at 64 thousandths of an inch per minute deflection. We're going to change it up, and we're just going to start crushing it after we remove the LVDTs. So you up the deflection to 1/8 of an inch per minute. The popping's getting more interesting, and it's starting to make some gravel there out of that beam, which is totally bent. It's interesting to see bent concrete, isn't it? Especially since it's still carrying over a ton. It's approaching 2 tons now. It's still taking load. And it's getting a little noisier as it runs along, but it's getting squishy as the cracks open. But it's making some bent concrete, which is quite amazing when you look at it. It's not too often you see concrete that bent taking a couple of tons of load, is it? We're still at 1/8 of an inch per minute deflection, and at this moment it's still carrying 1,700 pounds. Obviously, the tensile strength is a fiber. There's very little concrete left in there. When you stand back from it, you can tell that this is one seriously bent beam. It'd be interesting if we had LVDTs so we could see how much it got deflected, but I'm guessing that looks like 1 inch to me. At this point, we bumped it to 1/4 of an inch per minute deflection, and it's starting to shatter the beam pretty good now. It's still holding 1,000 pounds, but you can see the gravel it's making. That 1/4 of an inch a minute really hammered it. It's getting really squishy now. So we're going to stop the test when it gets to 500 pounds, which is right about now.